In this case, we demonstrate using our system to explore consumer transaction data based on what their shopping statistics at different branches. Suppose we want to observe whether consumers' shopping patterns among branches are different. We can perform dimensional reduction on high-dimensional data attributes formed by consumers' transaction statistics at different branches. A user can choose a reduction algorithm and reduce the data based on the attributes they're interested. Here we use TSNE algorithm to reduce the data attributes of a customer's transaction count and amount at each branch. There are several clusters in the distribution view, where each dot represents a customer. To further understand the characteristic of each cluster, we add a bar chart showing the transaction count grouped by every branch's ID. Here the user can choose any attributes they want to observe. We notice that branch 001 and 004 are hinted by our system, which indicates that the consumers of these two branches have a higher ratio of overlapping. Our correlation hinting method can guide users to explore data. We opened the information window. It reveals that 1,425 consumers have shopped at both branches. By clicking each bar, we can observe the distribution of each branch. A ring around the scattered distribution shows the categorical quantitative information of the data points. We can also observe the proportion of gender of the consumers. We notice the distribution of the consumers related with branch 001 is similar to that with branch 004. Meanwhile, we notice that the bar of branch S01 is hinted when selecting the bars of branch 001 and 004. By selecting the bar of branch S01, we found the consumers who shopped at branch S01 are almost distributed inside the clusters of branch 001 and 004. It can be inferred that customers of branch S01 is a subset of the customers of the clusters of branches 004 and 001.
In this case, we demonstrate using our system to explore further details. We analyze the shopping behaviors of the customers in the clusters mentioned in Case 1. We denote that the biggest cluster of intercepted customers of branch 1 and 4 as cluster CA, and two clusters that are correlated with transactions of branch 1 but not 4 as CB and CC, respectively. The color map of the distribution view can be changed to encode different transaction attributes of the customers. Exempli.cia, transaction amount, transaction count. Here we color the consumer data points based on their transaction count. We also can observe the value. It shows that the customers in CA have a large number of total transaction. On the contrary, the consumers in CC has lower transaction count and the consumers in CB only shopped once in a year. We are interested in what these one-time only consumers bought. Our system supports brushing and filtering, which help users examine individual clusters one by one. We take a closer look at CB by brushing and filtering. Then add a bar chart to analyze what kinds of products they purchased. We're curious about who bought those high-priced products. By selecting the value of transaction amount over TWD8000, adding the bar chart of transaction amount, and the function of coordinated multiple views, we found those whose transaction amount in a year is between TWD8000 and TWD20,000 tended to buy boutiques or luxury brands. We found that although this cluster represents those who shopped only once or twice at branch 001, over 30% of the consumers purchase luxury goods. On the other hand, those whose transaction amount is between TWD1000 and TWD5000 seemed to buy fashion apparel, fragrance, Japan groceries and care products more. To understand consumers more, we examine clusters CC. We take a closer look at clusters CC by brushing and filtering, then change the color map to view the transaction count and amount of each customer in CC. We found that those who shopped the least in this cluster surprisingly bought expensive products. To know the exact transaction amount, we expand the selected panel to check the raw data. The price of the products ranged from $35,500 to $150,000 NT. Next, we examine cluster CA, where the customers in this cluster shop frequently at those branches 1 and 4. By observing distribution view and the bar chart of shopping categories, we notice that most of the transactions were done at restaurants and supermarkets. Precisely, there are much more transactions about edible products than in clusters CB or CC. To observe the shopping behavior of the customers in CA who have bought luxury products, we select them using the filtering function.
Then we add a theme river to verify how and when those transactions were done. Theme river helps us on analyzing transaction behavior within specific time range.
As shown, these transactions seem to occur in a specific period of a year, such as anniversary sale or Christmas sale. We are also curious about the buying question mark behavior of consistent shopping consumers, so we set the color map to show the transaction count of these consumers, and then using filter to select the top 20% of consumers with high transaction count, who shopped more than 54 times in the year. We further select each bar in the bar chart and examine their distribution on the ring. We find that almost all of these customers purchase a certain category of products, like meals, bakery, and drinks. In this video, we demonstrate our system can assist analysts in exploring transaction data comprehensively, and analysts are able to analyze consumers' characteristics through different aspects. Select complex statistical attributes for dimensional reduction algorithm. Set the ring to observe the proportion of gender. Observe the percentage of shopping record in each month. Shopping percentage in January. Shopping percentage in February. Shopping percentage in March. Detected the phenomenon that the consumers with highest percentage are all projected at the periphery. Assume and verify the reason of the distribution pattern. Observe the change of distribution while browsing map. Shopping percentage in August is 100%. Shopping percentage in September is 100%. Shopping percentage in October is 100%. Curious about the temporal trends among months. Observe temporal shopping tendency of branches. Check the value of transaction percentage of December. Set filters of consumers based on shopping percentage in December. Filter the consumers who shopped 10 to 40% in December. Observe only the transaction trend of December. Observe the value of sum of transaction in December. Observe the differences among other groups.